Hello everyone. Today we will be going over the concept of HCF, or the highest common factor, also known as GCD, or Greatest Common Divisor. It is a crucial concept in number theory and arithmetic. The HCF of two or more numbers is the largest number that divides each of them without leaving a remainder. HCF is fundamentally used in simplifying fractions and finding common multiples. The first method we have is to list the factors of each of our numbers and finding the greatest common factor. Let's say that we want to find the HCF of 24 and 36. So, what we do is to start by listing the factors of 24. An easy way is to make them in pairs. Using this approach, we choose two numbers whose product equals 24. And we start from 1. Hence our first pair is 1 and 24, the second pair will be 2 and 12, then we have 3 and 8, and finally 4 and 6. We can see that the difference between our two numbers inside the pair decreases every time, and the remaining pairs, if any, will be in that difference. Therefore, the only option left is 5, which is not a factor since 24 is not divisible by it, indicating that those are all our factors. Now, we move on to making factors for 36, and we do it the same way. We have 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Now, 36 is not divisible by 5, so we leave that out. And our final factor is 6. There is no pair here since 6 times 6 equals 36. We then look for the common factors in both, and since we are looking for the highest common factor, we start searching from the right side. This shows us that 12 is the HCF in this example. The second method to find the highest common factor is by using prime factorization. This time, let's try two different numbers, 27 and 45. We went over this method in greater detail in the previous video to find the LCM. So, if something is confusing, please make sure to check that out. We start by making a factor tree for 27. Basically, we start dividing by the lowest prime number. Since 27 is not divisible by 2, then we move on to 3 and create the factors 3 and 9. 9 can be further divided by 3, and we end up rewriting 27 as 3 times 3 times 3, or 3 cubed. Now we can make the factor tree for 45. Similarly, we divide this by 3 because it is not divisible by 2, giving us the factors 3 and 15, which can be further divided by 3 to give us 3 and 5. Hence, we can write the prime factorization for 45 as a product of 3, 3, and 5, or 3 squared times 5. In LCM, we then looked at the greatest powers, but for HCF, we choose the lowest powers when comparing the lists, and if a value only appears in one of the lists, we ignore it. Therefore, we circle 3 squared only, which gives us the HCF of 9. Now, do make sure you try both examples using both methods to get better familiarized with them.
Pop quiz time. Find the HCF of 26 and 40. Solve this so we can finish this video.
However, before ending this lesson, let's do an example question where finding the HCF is useful. The question is, use HCF to simplify the fraction 24 over 36. We calculated earlier in this video that the HCF of 24 and 36 is 12. So we can rewrite the fraction as 2 times 12 over 3 times 12. The 12 is common for both the numerator and denominator and can be cancelled, leaving us with the simplified fraction of 2 over 3.